Today I'm going to explain my project about mobility path prediction and the human activity recognition. So first point is the human path prediction. So first of all, if I want to predict something, I want to first find one kind of algorithm which predicts some accuracy. So I already explained in my code video that how I have written down two test cases, and after these two test cases I find it out the accuracy of this. And here also you can see that this that prediction test number 2 has accuracy something nearby 0.44, while the prediction test number 1 has a accuracy nearby 0.9. And after that I have also drawn one chart which shows normally nothing, but it shows some longitude latitude ratio that it is increasing. And I also plot one graph. So here I will show you that how I can print one graph using latitude and longitude. So let me first find it out. Latitude, and in the y-axis I will draw some longitude. And here this is a scatter plot, but this scatter plot will show some accuracy, like from this point to this point I'm going every day, and after this graph I will predict for the future that for tomorrow this time I will be something nearby this point. So same way, if I am going from somewhere to somewhere, if I want to measure my physical movement, like I am walking or running, upstairs or downstairs, for that also I have created applications. So I will also show you my data set is. So this is for GPS data set is. For collecting a data, I have used three different applications. First is a GPS collector, second is a tower collector, and the third is a science journal to collect my physical movement. So in the tower collector application, I collect the tower locations, and uh, in the GPS collector, I will collect some data like longitude, latitude. So I will find out my physical position at what time I am where. So um, in my physical moment, I also collected all the data and generated one final data set. So in final data set, there are more than 4% data is collected, which has some activities like sitting, then walking, then downstairs, upstairs like that. So after collecting that kind of data, I have plot some graphs which shows that a person is sitting at that time or sleeping at that time. And here you can say this graph will shows you my activity for during the day for person, like for one day if I collect, for the whole day if I collect the data and create a graph, then it will show you that how much percentage of time I was sitting, walking downstairs or upstairs. So this application is basically used for the patient, or you can also use as your exercise, like if you want to decide that for 30 minutes at least I have to walk, or at least only 5 hours maximum I will sit unless I will walk or run. So by this application you can manage your task and you don't have to think more about it. You just have to show in the application, it will show you the graphs. And this also the graphs which in the accelerometer shows you that why if you are sitting then which kind of accelerometer graph it will create, if you are walking then which kind of graph, if you are upstairs then there is so much fluctuation in the graph, while in the downstairs all the graphs are most of in the downside. So all the graphs are taken as in a XYZ axis. So in the XYZ axis, if I am upstairs, my Z axis graph is upstairs. If I am downstairs, my X axis graph is downsides. And while I am walking, then the Z axis graph is showing downsides. And while sitting, sittings normally graph should be straight. So first is move, make some mystical movement, and then I sit, then it goes continuous. Like there is no movement, then it's a straight line. If there is movement, then it's fluctuating like that. So you can identify that which kind of movement you are doing during the day and how to manage that kind of movement. Thanks.